Now, the tangential speed of an object does depend on its distance from the axis of rotation. So if we consider two objects that are spinning around, maybe they're points on this particular wheel. Maybe we have a bug there, and maybe we have some mud there on that rim. That we can consider that the speed of each of those objects might be different. Let's take a look at the time that object A and object B might take to travel around that circle. We see that the time is the same, but clearly we can see that the distance that each object travels is different. The object that travels a greater distance is object B. Object B has the greater tangential speed, so it depends somewhat on where it's located. Now we're going to compare that, the tangential speed, that's different than what's called the rotational speed. Okay, so at some point down the road, we'll refer to rotational speed. Those two things are not the same. So how fast it's moving tangentially is not the same as their rotational speed. Now, if we consider that this motion is accelerated, it's accelerated not because of the change in speed, but because of the change in direction. So we can see that the direction of that velocity is changing. The acceleration happens to be in the same direction as the change in velocity. Let's go ahead and review what we mean by acceleration related to the change in velocity. So we defined acceleration as the rate at which our velocity changes. So if we consider that the change in velocity can be thought of as v2 minus v1, all divided by the time, we could take v1, remember how we subtract two vectors from each other, is we're going to define the negative of v1. It would be the same length, but pointed in the opposite direction. And then I'm going to go ahead and take that and add it to v2. So when I take negative v1 and add it to v2, what I get here, and draw that as a dashed line, that dashed line represents delta v. It points towards the center of the circle. So we can see that the direction of v2 minus v1 is towards the center of the circle, while the direction of the acceleration is exactly the same as the change in velocity. So it is pointed inward. And no matter where I look, we can see that that object has a tangential velocity. If it's uniform circular motion, the tangential velocity is the same no matter where I look. It's always traveling the same speed, but it is always accelerating. I'm going to use a different color here. It is always accelerating towards the center. So I'm going to use an acceleration vector called a sub c. Okay, so we have relationships between the velocity and the acceleration for an object moving through a circle.